Hi, my name is Scott Schote from AgileAssets, and this video is a brief introduction to analysis and optimization in our Bridge Analyst module. You spend lots of time and effort collecting a tremendous amount of data on your bridges. That data gives you a snapshot of current bridge conditions, and that same data can be used to take a look into the future in order to answer important questions. Questions like, will your current budgets ensure that you maintain the condition of your bridges? And what could happen if your budget is increased or decreased? Also, if your goal is to improve your bridge network to a certain level of performance, what annual budget will accomplish that goal? To answer these questions, you need a system capable of taking all that bridge data, analyzing it, and reporting on it to help you determine if you are on track with your current bridge network performance, and also to help you plan how you will meet your future bridge network goals. Another benefit of this analysis is that it can be used to help justify your budget allocations or even a possible budget increase for bridge projects. If we look at the basic parts of the Bridge Analyst system, the first component is bridge inspection data and the quality of that data. Next comes the tools which go into an analysis. Things like condition indices, decision trees, which are the treatments that get applied to bridges and at what condition they get applied, and deterioration models, which simply define how bridges deteriorate over time. Next is the optimization process, which uses an agency's goals and constraints, like maximizing your bridge network conditions subject to budget limits, and produces outputs, which are things like the best mix of projects to meet a goal, what the expected condition of bridges will be under budget constraints or other types of constraints, or even what level of annual budget it will take to get your bridge network to a certain condition level. This is the very basic structure of the Bridge Analyst system. Now let's talk about deterioration. This is a very important part of the analysis since it defines how a bridge's condition will change over time. Our system uses two main types of deterioration. For NBI level, which are the three main components of a bridge, the deck, superstructure, and substructure, we use a deterministic model, which is simply a curve derived from an equation. For element level deterioration, we use a probabilistic model, which means for each bridge element, we assign the number of years that we expect that element to stay in a condition state before falling into the next lower one. The software then automatically calculates the transition probabilities for that element's deterioration over time. So if we go into the system and first look at deterioration models applied at the NBI component level, this is what we have. Using a concrete deck as an example, the factor most affecting a deck's performance is traffic. So the equation that defines the curve for a deck will be driven by ADT, or average daily traffic, and the deterioration curve can be displayed here. Next, let's take a look at how deterioration is applied at the AASHTO element level. This is important because your bridge inspectors are in the field collecting element data, and each element's deterioration rate is different. To show how we include AASHTO elements and deterioration in our system, I will go into an actual client DOT environment. Let's first select one of the AASHTO bridge management elements, or BMEs. In this case, a pre-stressed concrete approach slab. As you see here, these are the number of years this element is expected to stay in each condition state. You can also see the curve and graph below for this element. If it has a wearing surface, as you see here on the next row, the element will last a little longer, so the curve and graph below are slightly different to reflect that. Now, let's look at bridge joints. These are elements that typically deteriorate rapidly, and you can tell by the curves and graphs here that it's little wonder why there's so much joint work being done out there at every DOT. You can adjust these models easily by changing the number of years in each condition state, and certainly use any models you've developed on your own. So this was a brief look at element level deterioration models in our system. Now, let's briefly look at decision trees. What is a decision tree anyway? It's how the software decides what treatment to apply to a bridge at each condition level. How does this look in the system? In this concrete deck example, lighter preservation type treatments get applied when the deck is in good condition, and as the deck's condition worsens, other treatments get applied, like patching and crack sealing. And when the deck's condition is really poor, the treatment is either a heavy rehab or a replacement. Now, where do these treatments come from? These treatments are the specific treatments your agency performs, and the system also includes the cost of these treatments. Please note that decision trees are fully editable, meaning that if you decide that a different treatment should be applied at any condition level, you can simply change it to a different treatment. In this case, we'll change patching and crack sealing to a more heavier treatment, which is deck rehab. These decision trees are at the large component level. In order for the system to produce work recommendations at the element level, each bridge element needs its own decision tree, right? So we have decision trees for each type of joint, for each type of bearing, for each type of material and girders and beams and piles. Oh my! You can imagine how many decision trees are available in the system, all driving the treatment selection process. Now, I'd like to talk about our optimization analysis. It is unique in the industry because it allows you to set up a scenario with multiple objectives and constraints and run a single optimization analysis which accounts for all objectives and constraints simultaneously. Let me give an example. Let's say my boss at the DOT wants me to run an analysis which limits my budget each year and also limits deficient bridges on the system each year. On top of that, I also have to meet a minimum condition for bridges on each separate highway system, like the interstate versus NHS versus RHS and SHS, and also give different budgets to preservation work, rehabilitation work, and replacement. I used to try running this type of complex analysis with other systems, and it was impossible without going through multiple iterations. I would tweak the annual budgets to see how deficient structures were affected each year. I would run a separate analysis for each highway system and so on. Was I getting solutions? Yes, but I knew they weren't the best solutions because I was only solving for one issue at a time, rather than finding the solution which met all the criteria simultaneously. Our system provides you with the ability to run realistic scenarios which produce work plans that meet all the objectives while simultaneously complying with all constraints. Let's return to the system for a look at some analysis. Going into the analysis window, let's first talk about the layout of the window. On the left-hand side, you can see a window titled Scenarios. This is where the setup of the scenario would be done. This is where you name the scenario, select the year of condition data, and also select the analysis length, as well as some other options. Going to the top right pane is where you set up all your objectives and constraints. These are the limitations on your budget, the goals you're trying to achieve, and things like that. At the bottom are your reporting functions. The software can report a number of different things, and this is where you would set that up. Let's look at the results of an analysis at your current preservation funding levels. If we click on the Results tab, you can see a list of work that is recommended for each year of the analysis. This is a 10-year analysis, so there will be work recommended for years 1 through 10. You can see here there's deck, superstructure, and substructure work for this particular structure, and if we select another one, same type of deal. Now, if we go to constraint results, you can see the constraint limit value is basically the amount of money you have each year to spend, and the resulting value is the amount that the system spent to try to meet your goals. In the Report tab, you can see a graph of what is expected to happen to your health index over the years with these budgets applied. Now, let's take a comparative look at different budget scenarios on a map. If we go to the Reports tab and select GIS Map, you can see I've gone ahead and run some scenarios at different funding levels. One is at your current funding level, one at a 20% increase in funding, one at a 20% decrease in funding, and one with no funding at all. Looking at the map, you can see your current bridge conditions as they stand today. You guys are well known for having some of the best bridges in the country, and you can tell on the map with all the green dots, that's certainly the case here. Now, at the current funding scenario, 10 years out, this is what you can expect. The color coding is basically green for good bridges, yellow for bridges in good to fair condition, and red for bridges in poor condition. So you got a couple of red dots cranking up there. At 20% increase in your funding, what would happen? you can see a little more green on the map, so your bridges are increasing in condition overall. If you experience a 20% decrease in funding, you can see more red dots appearing on the map, which means your bridge condition is worsening. And finally, with no funding applied, you see a dramatic decline in the condition and quality of your bridge network. This, of course, should come as no surprise, as it's kind of unrealistic, but at the same time, it's good to see what could happen as budgets change. This completes Analysis and Forecasting, Item 11. Thank you.